Welcome to Quick Geek. Tonight we're going to talk about databases. With me, hopefully I've got two chaps that know something about the subject. I've got Tim Haak.
Hi.
And Jan Vermeulen.
I'm just here for the food.
What food? Okay, let's jump into this. I've got some questions. Gentlemen,
Okay.
What is a database? What defines a database?
It's a horribly complicated question, but essentially at the end of the day, it's a system that stores data.
Yeah, and allows you to retrieve it in some sort of sensible manner as
Yeah.
well.
But a spreadsheet does the same thing.
Technically, you can classify a spreadsheet as a database.
If it's used in a certain way, absolutely.
Okay, so
Well, it's a table,
I wouldn't call it a good database.
Yeah, it's a completely flat structure.
Yeah.
So
Look, normally though, when most people speak about databases, they're actually thinking about SQL databases or SQL compliant. You know, there's different versions of SQL that you can comply to, and they're actually talking about RDBMS, which is relational databases.
okay.
and SQL is one type of.
Well, that takes us into
So,
my
I mean,
next question.
So what does SQL mean, right? That's a way to get the data out.
Yes, structured query language, and it's normally something that's specifically related to RDMSs, which is relational database
Management
systems. You know, to name a couple that are quite popular is MySQL is one of them, Postgres,
that's
Oracle.
all SQL.
These are all RDMSs, and they all have SQL interfaces.
Let's not forget Microsoft SQL Server.
Yes, SQL Server, as they love to call it.
Access.
That is SQL.
I hate Access, so technically it is. But if you want to lose your data very quickly, use Access.
Okay.
Now we have seen Access work quite nicely. It's for people wanting to do very quick
Mobile databases.
interfaces to databases.
Okay.
It's very easy. But then what you should rather do is have a real SQL database sitting behind it. The big problem with Access is it's got a single file, and when it's on a shared server and multiple people write the file, it goes corrupt very quickly.
Okay, that makes sense.
It's not designed for multi.
Okay, but now you've only mentioned SQL. Are there any others out there? What does Solaris do? Is that also in SQL?
Solaris is an operating system,
Yes.
if I'm not mistaken.
Okay.
Solaris is there are some older ones. So Adabase, I think was one. No, Adabase is a programming language.
Yeah.
So I think of the older ones. I haven't worked so much with the older
So
databases.
Good old
SQL
DBase.
at the moment is the
It's the
base.
factor standard. There are some older ones that the banks uses. There's some newer ones that they're called the NoSQL movement.
Okay.
Which is actually it's more the no relational model movement,
Okay.
because some of the NoSQLs have SQL-like languages.
Right.
Right. So it's not actually about the query language; it's more about the relational model behind it, and that's got to do more now that as data is getting bigger. We're hitting problems with scalability.
Now, can you not use flat files as a sort of a database?
Of course, you can.
Or would that still be classified as a SQL query?
SQLite uses flat file, right?
No, not a flat file.
Okay.
It uses a file. They all use file-based systems.
Yes,
So
yeah,
they all
so
go into files.
But it's a single file.
Yeah, no. Technically, the term a flat file actually refers to I have a file that
Like
I've
a
just put
CSV.
lines in.
Yes.
CSV would be a flat file.
Okay.
So SQLite is not.
CSV is as much a database as a spreadsheet is a database,
Yes.
I think, which is not much.
Okay, that's a good answer. Now, the debatable question: which operating system
Linux.
would host the best?
Linux.
You didn't even have to think.
Hands down, Linux. Sorry, Linux.
Okay, quantify.
The main thing with databases is they tend to be very heavy on your writes and your reads, and you want nothing else interfering with that.
Okay,
And with Linux, you can get rid of
all the overheads.
all the overheads and stuff like that. So you can maximize your RAM usage, you can maximize your hard drive access without any system suddenly kicking in trying to index your file system.
Okay, but that then kicks out the Microsoft SQLs and.
Look, I'm not saying they're bad databases. We're talking high-end, optimum, bang for your buck. Linux is the best. You then have downsides to it, right? If you don't know Linux, it's harder to use. If you know Windows, look, at the end of the day, if you know Windows and you want to put a quick database together, don't go learn Linux to do it. Go get the database for your system and start working on it. Just be aware that once it grows beyond a certain size and you're wanting to do...
But you can run MySQL on Windows.
Yes. You can run virtual servers on Windows. You can run there's Sigwin, which is quite nice. You can run Postgres on Windows directly, natively now. For the ones you can't, there's Sigwin. Look, for some of the NoSQLs, so like the Cassandras, the Hadoops, the I think CouchDB's in there as well. You can't run them on Windows. You've got to run them on Linux.
Okay, so now let's just settle on Linux.
Yes.
Right? Now let's settle on a flavor of SQL.
My favorite would be Postgres.
Postgres.
Yeah.
All right.
Look,
MySQL, I mean, has its place.
Yes.
I mean, if you are running a WordPress blog, WordPress, interestingly, used to support Postgres, but they abandoned it. You know, when MySQL had that surge in popularity, I can't put an exact timeline to it now, but MySQL like just suddenly became the like sort of de facto standard for a basic web app.
Okay.
And so I think for the simplicity of development, WordPress abandoned support for Postgres, and also most shared hosting systems. Those are, you know, where multiple people who want web hosting space share the same server, but also the same server instance more specifically. So it's not virtually private or private in any way. They typically use MySQL, PHP, that sort of thing. So MySQL, just from sheer popularity, still has
and its
place.
background, but Postgres is coming up faster.
Yes.
One of the big reasons I think Postgres wasn't around so much, is it wasn't quite as fast as MySQL previously.
Okay.
And secondly, Postgres you couldn't run natively on Windows. You now can. So
Okay.
as soon as they made that change, not only have the popularity's gone up, the reason I like Postgres more is it gives you, there's a lot of certain tools that it gives you that MySQL doesn't give you. I'm not sure, but there must be there were certain licensing issues with MySQL when we started looking into it.
Okay.
And subsequently, I found Postgres, if you tune it properly, it kicks ass.
Let's then stick with Linux and let's go.
I must be honest. People are going to hate me this. My favorite database of all is still Oracle, but you pay for it, so cost effectiveness is not a good option.
I think Oracle started getting hammering when they started putting file blogs into the database, because they were going around in the video industry going, no, you can put your raw footage into the Oracle database. But let's not go there. In any case,
there are some immediate reactions from IRC, which is Oracle. Now talking about, I know we've sort of put the operating system question to bed, but I've got to hang out with the HP guys quite a bit, the enterprise guys, and they've got those HP server stacks of theirs.
Look, that's a different league.
yeah, let's not go. No,
that's a different league of things. At that point, you're hiring a company to come and build you a bespoke system. You know, and then it's like, well, who have you hired? At the end of the day,
because you want to go that league, you can throw the SAP in there as well.
Yeah, SAP is just software, right? So, but IBM you can throw in there because
IBM,
they run their
you
own
can throw
stuff.
Oracle in there.
Yeah, so let's
they'll
not
come
go
out
there.
if you're doing that. Then I'm sure they'll do bespoke development.
It is the reason Oracle bought Sun, right?
Okay, let's just stay here.
Okay,
right?
so we're talking more.
So now we've decided Linux, Postgres with MySQL. Okay, let's stick with that as a base. Yeah. Otherwise, we're not going to get far. All right.
And I must be honest,
my next question
is Microsoft SQL Server in quite a while.
Okay, let's just stick with those three options for now. Now let's go on to clustering. Which of them would support clustering?
Define clustering.
So you've got a couple of options.
Yes. Okay. Now in clustering, there's different things here. Now you get replication.
Yes.
Which is I duplicate the data.
So it basically takes the database, it adds a unique number at the end, and it actually duplicates all that data between multiple servers.
No, it doesn't add a unique number. It literally does a mirror copy.
So
there'll be some software
both ways.
You can do. That's master. Normally it's master slave.
Okay.
I know Postgres recently introduced master-slave chaining. I think it's called that, where if you replicate to the slave can replicate to further slaves.
Okay.
So you can chain your replications.
So the idea behind that would be, as master goes offline, you can actually go into slave.
Yeah.
But it doesn't actually. How do you know your SQL is getting to maximum load of your server? Can you not share the load over multiple servers?
Well, you see that's why you would replicate. Oh, look, use replication for backup. And look, I just want to say there's something called, I'm not going to blank on the name. So if you're not worrying about replication for what you're talking about, not just purely for backup, there's a bit that will actually even do replication of hard drive. So then it doesn't matter what database, look, it's going to be Linux, what you're using, and then it'll do full replication across.
I'm just asking, if you've not hit the maximum of the hardware you've got available, can you not cluster them over multiple hardware?
Right, but then you need to write your software. You either need to put a proxying system in front of it.
Yes.
So let's say you've done your replica, you copy your two databases, you've done it in a master-slave way, and your problem is reading. So now that you can then copy to 10 servers. You can then distribute your reads across all 10 servers.
And keep your writes to the master.
And writes to the master. There are other ways you can, if you write your software correctly. Where in software you do, you can say, I write this information to this server, this information to this server, this information to this server, and then you can replicate your writes. A lot of the databases natively don't support sort of generating a invisible cluster very well for you. Generally, that's where the NoSQL servers come in very, very, very strongly. I know, like for Cassandra, it's one of its big things. It's very easy to build this cluster with replication factors and stuff like that. And if you need more, you just add another one onto it and just keep on doing it, and it's very little overhead to do. You lose a lot with that.
Okay.
So like with SQL, you lose a lot of your tools. It's a lot harder to work with. With NoSQL, it's a lot harder to work with and get the data out and push it back in again. But with that, you can get scary speeds out of it.
Okay.
It's you working far closer to the metal, as they call it.
So just on that, I mean, you spoke about having to have a proxying system. As soon as you start clustering, you need to have a proxying system to make sure that the load is distributed. Now with Cassandra, do you still need to do that?
No.
Is it more to not... Sorry, on the proxy, is it more to ensure that the queries are distributed then?
You get proxying system that will
Double
distribute. Okay, let's start with the proxying for normal SQL RDMSs. It's like MySQL and Postgres.
Mm-hmm.
With those, they can both do writing distribution and reading distribution.
Okay.
So you now speak to a central thing, and you can do that in an HA, which is high availability. So you can have proxying systems that can be in high availability. So if one fails, another one steps in, and it will distribute your reads and writes to multiple servers. There's a lot of overhead in managing those systems, is what I've seen. So if
physical overhead or process overhead? I mean,
human overhead and setting it up,
okay.
making sure it's all working and managing it. If you're working with static systems and you're building systems, then it's a lot easier. If you're in a dynamic environment, it gets a bit harder.
Okay.
So I know we deal with a lot of where we install servers at multiple clients, and tomorrow they run off. Then it gets a bit more tricky. You can do it, but it's not natively. I know Postgres is heading to have it natively built into the database, and I wish they had it right now because I would love to be able to use it.
We'll be going there.
Normally, how most people handle it, though, is that they'll handle it in the application logic. Unfortunately, if you haven't written your own applications and you're running something standard, I know you guys have this problem, it becomes a lot harder to then do. So that's where you would then want to show the proxies in there.
All right. Moving along.
There was a Cassandra question.
Yes. So about Cassandra, Cassandra's clustering, now all of a sudden you don't need.
Yeah. Now with Cassandra, it's got algorithms. So look, you add a device into it, right, and you give it a sort of an ID in a round robin. So you've got, I can't remember how big the number is, but it then says, depending on where that number is, you can think of the number as a large circle. Where that number in the circle is where you are in getting the data. Let's go even simpler than that. If I write, let's say you got four cluster Cassandra, and I write data to you, right? And you're using the randomized storage thing, and I give you enough data. You're going to accept the data, and the data you need to store, you'll store. One quarter you'll give to the next server, the next quarter you'll give to the second server, and the next quarter you'll give to the fourth server to store, right? But I can even chain my writes, so I can give you one set of data, you'll sort of split it up like that. I can then give a next set of data to the next server, next set of data to the next server, and just keep on going around. So normally, Cassandra is designed for very, very heavy writes. So if I've got heavy writes, I can just, I think they can scale up to hundreds and thousands of servers in these chains, and I can be writing to all of them at the same time, and they'll then be working out where the data must be going.
Okay.
And handle all of that for you in the back end without you even worrying. And the beauty about that is you don't need to worry about it. Things like that. Look, the other DB, NoSQL DB is the one I've been playing around with a lot, is Couch, where its power is not so much for things like that, but if I want to replicate data, it's very easy. Literally, you put you send it a line of, I have a server here, I want to replicate that database, and it starts replicating. And in a while, you have a direct copy, and then I just connect, and I can work on mine. And if somebody else wants a copy of me, I can just copy it that way. So it gives you very...
So it's a built-in command for replication.
Yeah. So,
but now talking about replication, I want to ask the question backups. What is still the safest way to backup a SQL database?
A SQL database.
Yes. I'm going to ask...
for HA or for data redundancy?
Data redundancy. Still the SQL query?
Dump it.
SQL
MySQL dump.
SQL dump.
Well, look,
SQL dump.
they say the the HA stuff is not that bad. Your main problem when you hit large, heavily servers, you don't want to have this dump running. You're going to kill your server.
Yes.
So, there's all factors in there. So what do you mean by safe? So in that run, you must want to be running an HA of some kind of, it's replicating, a continual replication, so the load spread out over a long time. And then when I back up that server.
Okay, that makes sense.
And the advantage of that is then also now, if this server dies, I can just switch over to that server. And
you can always use the replicated server for SQL dump if you want to still do the dump.
Yes. So
dump, a copy is still the best.
Yeah.
Okay, now, what is database optimization?
It's
Short.
optimizing. It's a very, very big question. Normally what people mean is it's basically reducing load and then and improving speed of interaction with the database.
And what tools are
Okay,
generally available?
the one I've been working with recently, I'm not
Yes?
that proficient in it, is MySQL. I'm proficient in Postgres quite a bit. With MySQL, there's a couple when MySQL Tuner is quite nice to run. It's just a Git
Part of
apt-get
the
install.
distro, something you can just install.
Just install very quickly in Ubuntu. You just apt-get it comes down, and what that will do, actually look at your configs and your running logs, and it will make suggestions on what tuning you need to do inside your configuration files.
Okay.
Then there's another free. These are all free ones. I'm talking. I've
Yes,
lost MySQL SLA, which you've got to download. It's not part of the thing, and they will analyze your logs for your top queries.
Okay.
Now, in that thing, you should also be tuning your, I think it's log slow queries. There must be log slow queries for things without indexes. I can't remember the exact term. It's basically for joins without indexes. I know for the one that I was saying, the joins without indexes wasn't turned on.
So is that a feature that you switch on the SQL server?
On the MySQL server, and then it writes a log
got
file.
variables to say, I want to know queries running longer. Is this, or is it a default?
You can specify the length of time that's important.
But then it actually dumps the queries it was processing into
Yes,
a file,
with the
text
time,
file, so you can actually
how
process.
heavy it was, and all the rest of it. One big problem I'm seeing with that is if you've got a server that's on a heavy load, it can pretty much start dumping every single SQL statement that you have. And the problem
So
is
it goes into load and then starts because
Yeah,
then everything
just gets slow, and it sometimes becomes very hard to, at the end of the day, find what is slow. With the tuning on the MySQL, basically what at the end of the day you're trying to do is tune the RAM usage,
Yes.
so that it uses as much RAM for caching. And just to give a simple reason, hard drives are slow. So if I'm doing a select against a hard drive, it's relatively slow. It will always be for large amounts of data. But when you make that query, it's going to actually pull all that data up into RAM and then do something with it to return you the data. Hopefully, if you have enough RAM, it's going to leave it there and leave ones that are commonly used. So the next time you need to pull the data, you're not going to pull it off the hard drive. It's just going to pull out of RAM. And it will handle when you're writing to it, that writes back to a hard drive. There's a whole bunch of syncing
Well, that
and
comes from an operating
fsync
system.
and no, you can tune even that down in the configuration files. Now, look, on Postgres, which I know a lot better, you can tune that. Do you want safe writes? Do you not want safe writes? If you turn non-safe writes off, you get much more speeds with writes. But if you crash all of a sudden, you can lose data. You then can also tune you can tune your file system in the FS tab to be more secure or less secure, to give you more speed.
Okay.
Look, you can get horribly complicated with this stuff.
But use the tools and they're going to give you some good guidelines.
Yeah, for MySQL is that one. For Postgres, and also use explains. So if you're the guy actually writing the queries, use the explain tools, and what it does explains how that query will run. I looked at the MySQL one; it's not as useful. The Postgres one, to me, makes more sense because it's a GUI and shows you, tell you which indexes did it do a full table scan. Just explain. A full table scan is I have to go through the entire table to give you a result.
Okay.
Where an index scan is better. Now, what an index is they've basically gone and created on certain columns.
Reference that.
Call it a smaller table. That's a lookup, and it's B tree, so it's go look up B tree. I can explain it now. And so it's smaller. So when I need to query your table, basically I load the small amount of data off the hard drive.
Find the right record.
It's
and
easier
then use the record.
easier to store in memory. It's quicker to search through. And it will tell me which results in the bigger table I need to do, and it only then pulls that data off the hard drive.
So indexing is important.
Index is great, but also don't go too many because there's a cost to writing indexing. If you start indexing every single column in your table, your writes are going to become horribly, horribly slow, and once again, more load.
Okay. So you've got to weigh it up.
It's all these things are way up. It's index. Also, if you have small tables, don't index them, because if I think it's between 100 and 1,000, it's as quick to just write off the hard drive, and now you're putting load on your server writing indexes.
Now, another quick fix that you mentioned in the week was defrag the tables.
Yes. I was surprised to find MySQL does this. I know PostgreSQL, it's called vacuuming.
Oh, vacuum. Okay.
It's called vacuuming.
What is it? I mean, is it actually on file system level defragging, or is it defragging?
Yeah, it's basically how these databases are effectively optimize the writes to the file system for quick reads. So, look, I'm talking more from PostgreSQL, which I understand better, is as they're writing your rows, they leave spaces so that they know exactly where to look for the next row, right? And in that, they might have overestimated it. So that's one thing. So you can get it closer. You can compact your database to make it smaller. But also, if you're deleting and changing your data a lot, so there's a lot of thrashing in the data, if you want to call it that, you land with these huge gaps. But it still needs to scan through the gaps sometimes to find your data. So there's a slowdown there. So if you vacuum it, you then shrink all that.
Take out all the gaps.
In, so it's quick to find the data. Secondly, there's also re-indexing. So if you've got indexes, once again, this is normally a lot of the stuff for data is changing very often. You want to be running re-indexing because you might have stale indexes in there that they'll be marked as bad, but it still looks through that and it just gets it all compacted again. And that can also have quite a nice speed improvement when you've got large data sets.
Well, another thing, commitment of log files. This I know is a big problem on Microsoft SQL. And if you are running a Microsoft SQL file database, make sure you go check the commitment of log files. Is this the same one on Postgres and MySQL?
Commitment of log files? Just explain what you mean. There might
Microsoft log files, they keep a record of every transaction ran against a database for failover purposes. And then that file can grow to filling up a server. So you actually, I'm not sure about the latest my MS SQL, but the previous versions, you actually had to set the commitment of those log files into the database to happen, otherwise they wouldn't.
You do have similar things like that in Postgres, I know, and it's for recovery and stuff like that. The wall files, I think they're called, and it's WW. I can't remember what the acronym stands for. It actually stands for something.
Yes.
Something logs, I think. And it does use that for replay. So if your database crashes horribly, it does use that to replay and try to recover your database. It handles that pretty much for transparency. Sometimes if we're talking now more speed, they do recommend you write that stuff to a separate hard drive so that you can write and whatever, and those writes don't interrupt your normal writes to your hard drive.
Friday Roadkill in the RC, and I know he works with Postgres quite a bit, said that you can configure that log on Postgres.
Okay.
Other comments?
I know these configurations, but I've never had it grow too big.
And other comments from just on the SQL dump. Sorry, I know it's going back to a previous topic, but just to mention what's coming from the RC, is that you can limit the load. There's an operator to limit the load of SQL.
Slow load, but look, are we talking about the DB I'm talking now here? We're hitting things like 80% IO weight. At that point, I don't want to do any dumps. But now, how do I back up my data? Because it's more very heavy things that
look, if anybody out there, I hope this has been informative. If you really want to play with some good database to try and get your skills up going, go check out the Wikipedia offline version, which gives you lovely databases you can download and commit.
I'd recommend Postgres.
But go have a look.
Gives you a GUI.
Go have a look at those databases. I've personally tried to actually commit those. They load beautifully up to the point of creating indexes.
Oh, you're talking about the loading the Wikipedia one.
Loading the offline Wikipedia version. So if you really want to test your SQL skills, go have a look at those tables.
Cool.
Thank you, gentlemen.
Thank you.
Thank you.
Have a wonderful evening.